Good morning, children. My voice is audible. Right. So the previous classes we discussed about the black one and also started the Shravan, right? Now we started the organic part. In that basic concept of the organic part, I started with the classification of organic compounds. So this chapter is very important for the regarding of organic chemistry to understand easily. What my concept I want to reveal to you is organic chemistry is easiest chemistry in the total. If you understand properly. If you are not understand properly or you are not listen that one, this is the very hardest one in that chemistry. The two angles are there. Okay. So please try to understand the concept, basic concept. If you are understanding the basic concept, it is fingertips only. Nothing but fingertips. Just like the mathematics, every time I will say like that only. So organic mainly classification, you understand the classification. Open chain compound, cyclic compound. Open chain compounds are nothing but again you are classified. Open means the carbon atoms are arranged in the open. Then that is what that is. Okay. These open chain compounds are again further classified to saturated, unsaturated. Saturated is the example of alkenes. Unsaturated means alkene means it is carbon in between the single covalent bond is there. That is called as saturated. Unsaturated means there may be a double bond or triple bond between the carbon atom. Those are called as unsaturated. Now coming to the cyclic compounds. In the unsaturated compound, we are classified into alkenes and alkynes. Double bond is called as ene and triple bond is called as ine. That is cyclic compound means again you are classified into alicylic, cyclic compounds and aromatic compound. And also one more is aromatic compound. That is heterocyclic compounds. So acyclic and aromatic. Acyclic up to acyclic you are having in the first cell. So acyclic means only the saturated hydrocarbons are arranged in the cyclic form. Saturated means immediately consider it is a single bond. Only single bond is present between the carbon and carbon. Whether it is open means it is called as alkane, alkenes, alkynes. If it is a cyclic means it is called as cyclo, acyclic. Cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane. Like that, we are having up the acyclic compounds. These are called as alicyclic compound. Then aromatic means there is a alternative double and single bond is there. Aromatic is a compound, specifically benzene. We are classified in that. It is an aromatic compound. Next, further classification, that is heterocyclic compound. Apart from the carbon and nitrogen or oxygen or sulfur or halogen will be present. Those are called as hetero. Hetero means different atom. Those are called as classification. Next classification, actually I taught that one in the last Sunday. So organic compounds are classified on the basis of functional group. It is also a long question in your examination. Very simple. On the functional group, you are classified the organic compound again. That is, total organic compounds are classified on the basis of that one, carbon and hydrogen. Here,
sir, can you repeat once again which question is important?
Sorry.
Can you repeat once again, sir, which question is important?
First thing, I don't want to listen at the word is important. I am using a basic concepts only. Leave it with the important. Everything is important in the organic part. Okay. So first is the classification of organic compound over one question. Now you are classified the organic compound on the basis of functional group. This is a question, second question in the organic chemistry. Okay. So now you are classified this particularly organic compound. Only the elements which are having a organic compound, that means hydrocarbon, The hydrocarbon means carbon and hydrogen is present. Those are called as hydrocarbon. On the basis of that carbon and hydrogen, you are classified as a functional group. So, classification of carbon compounds. Organic compounds. On the basis of functional group. Okay, this is our topic today. On the basis of functional group, I am taking only the first classification is the carbon compound is having of carbon and hydrogen only. So I am taking in that A. So you are taking off. This is the compound. Okay. It is nothing but alkane, saturated compounds. And this is an example of what? C2S6 is a ethane. Ethane is the structure. Air is the you are having of that one. This is only carbon hydrogens are present. Carbon and hydrogen only present. Now if you take the second one, I'm taking off a double bond. That means this is alkene. Only carbon hydrogens are there. Not more than that. This is the name is the compound is ethene. If you take the same one, I'm taking off one more triple bond. If you observe that in this element, a compound having of only carbon and hydrogen elements. This is called as alkyne. It is called as ethyne. Common name is different. It is ethylene, it is ethylene. Okay. Now, on the basis of the classification of the functional group, this consisted of only carbon and hydrogen. Those are classified into three categories. Right? So, if you see, remember easily to write in the examination when you are following this particular or you are attending the class attendance of the class is enough for the writing of this particular chapter. Okay, that much you have to having of the capacity. You write easily by means of observing of the all the compounds by means of that one. Now, carbon and second classification I am using of carbon, hydrogen. And also one more oxygen is there. If you suppose the oxygen is there, in that I'm classifying the organic compounds. First A, I'm using of the simple the compound, whatever the chain. That particular chain consisting of carbon, oxygen is present. This is the functional group is called as carboxylic acid. This is called as carboxylic acid. So in your exam, this is enough. This is called as a carboxylic acid. So now we are using this carboxylic acid. Suppose in particularly I am using of R, alkyl group. Okay. This alkyl group I am keeping of the example of methyl group, CH3COH. It is nothing but the name is acetic acid. So in the examination, you are classified on the functional group. You classify this is called as carboxylic acid. The functional group is called as carboxylic acid. I'm giving the example instead of R, I'm taking up the methyl group. It is called as a methyl acetate. That means acetic acid is a common name. Okay. Now, one more you can take. See, we are focusing on this one only. It is called as aldehyde. The functional group is called as aldehyde. That means in any organic compound, CHO is there. You have to name it as aldehyde. If it is a COOH is there, it is called as acid, carboxylic acid. Now I am taking off. Same, I am taking methyl group. So it is called as acetaldehyde. It is called as acetaldehyde. I hope you are understanding this one. Okay. Very easy. Right? Coming to them, one more you can take. Aldehyde acid is over, aldehyde is over. Okay, I'm taking the ketone. This is consisting of a double bond on the carbon atom. It is called as ketone. Example, instead of R, I'm taking of CH3, C double bond O, CH3. This is called as dimethyl ketone actually. It is called as acetone. Common name is acetone. So, common name is acetone.
Sir, if we study just common structure, we can write any number of examples.
Any number of example. If you are using R, that's why I'm not changing the R. See, S3 I'm using because you don't want to confuse here. Okay. If you take this is a methyl group, it is ethyl group. Okay, no problem. Both ethyl group, no problem. Ethyl ketone or methyl ketone. That is the nomenclature is there. After this chapter, the means topic, we are having up the next topic is the nomenclature. Is on the basis of nomenclature, we can name it as a compound. I'm taking generally, this is a acid is over, aldehyde is over, okay, ketone is over, okay. One more is a ester also there, and also ethers also there. So, what are the esters? What are the ethers means? We are having of the in the examination, three examples enough. Why? Because classification is consistent of 10 marks question. So I'm writing one more. RCO. Okay. CO. R directly I type ROR like that simply. If you don't want to confuse here again. Ether. This is called as ether. Simple. You can take the example of dimethyl ether. This is called as a di. 1, 2, di, 2. Dimethyl ether. Okay. One more is there. In the C, I'm using only carbon, hydrogen, oxygen. That's it. There's no other elements are there. R, O, R. This is double O is there. It is called as a ester. Okay. So, methyl, ethyl ester or dimethyl ester. I'm taking the same one. CH3, OO, CH3. Dimethyl ester. So these are the enough for your classification under the carbon, hydrogen, oxygen. So carbon and hydrogen only 3 saturated hydrocarbon and 2 unsaturated. Come under oxygen, we are using of this one. Okay. Now I'm taking the third classification. Carbon, hydrogen, oxygen. I'm taking also one more nitrogen also present. If suppose in organic compound consisting of carbon is there, hydrogen is there, oxygen is there, nitrogen is there. So that I'm using of the one simple, okay, NO2, nitrate, R, alkyl. Alkyl means it is consisting of CH. Carbon is there, hydrogen is there. Alkyl nitrate. This is called as a functional group is called as nitrate. So simply methyl nitrate or nitromethane. Whatever you want, both are same. Nitromethane or methyl nitrate. Okay, NO2, oxygen is there, nitrogen is there, carbon is there, hydrogen is there. Okay, these are the elements which are having off. And one more in this, not more than I will take that one. Why? Because we are having the nitrate is there. Okay. Next one, we will see the amide group, that is CONH2. Amide. This is called as amide. We can use as acetamide, CH3CONH2. Acetamide. So how the classified on the basis of the functional means these are the basic of the these are the main important functional group. Carboxylic acid, aldehyde, ketone, ether, ester, nitrate, amide. Okay, these are the important. Next, fourth classification. I'll take on the top again. The fourth classification is carbon is there, hydrogen is there, nitrogen is there. Okay, carbon, hydrogen, and nitrogen. These are the three. That I'm removing the oxygen. This one. Okay. So simply, this is called as amine. So if you are taking of methylamine, methylamine. You can take them with primary amine, secondary, tertiary. Also, how many are there? Okay. Now, one more. I am taking of carbon, nitrogen only. This is there. Means it is nothing but Cl. Simply we are using as Cl. But because a triple bond is present between the carbon and nitrogen, that's why we are writing up the structure. It is called as cyanide. Cn is called as a cyanide. So the example is methyl cyanide. Methyl cyanide. Okay. One more is, see, just I'm taking out that one. NC instead of Cn, just I'm saying this is called as
Isocyanide.
isocyanide. Okay. So I'm taking off methyl isocyanide. NC. Are you heard about this name anywhere?
Yes, sir.
Where this is a big tragedy in our India. Very big tragedy. In the 1988, December,
About
December 23 in Bhopal.
Yes, sir.
In the Bhopal, Madhya Pradesh, the tanker is blasted with the isocyanate. This is a methyl isocyanate. Almost all 20,000 people are died on the basis of this methyl isocyanide. Methyl isocyanide. Okay, these are the bases of carbon, hydrogen, nitrogen. That's it. It's enough. Okay. Still, if you want to go to any others, why? Because this classification is only carbon, hydrogen, oxygen, carbon, hydrogen, oxygen, nitrogen, carbon, hydrogen, nitrogen. Sometimes halogens are also there. Sometimes carbon, hydrogen, and halogens. So I'm taking off X, simple X. This is called as halides. So methyl halide. X is anything you can write. Okay, chlorine, bromine, or iodine. Mostly chlorine, bromine you are taking. Why? Because fluorine is a very small atom. It is a very fast reaction. The rate of determined reaction step you can't determine. Iodine is very slow reaction. Only in the organic compounds we are using with the halogens are chlorine and bromine. So methyl iodide. Methyl. Suppose I'm taking off X, instead of X, I'm taking off HI, methyl iodide. Okay, these are the enough for the functional groups of that one. So for the examination point of view, almost all 3, 6, 7, 7 plus 5, 12, 14. If you are writing the 14 example, means 10 marks out of 10 marks, will get the 10 marks only. It's nothing is there. It's a mathematical, a numerical form, words, all are. Just remember these are the important. These are the important. And write the one example for that. So here, you don't want to confuse. I'm using here R, alkyl group is only methyl. Anyway. So it is easy to remember in the examination. So this is about the functional group of the organic compound on the basis of, that means the classification based on the functional group. Okay. Now we'll go to the next topic. Okay, clear now? This one is a very, very important in the examination point of view. Not only the examination point of view, the nomenclature also. You have to identify. Suppose if you are, this is appears means you can immediately strike it. It is an acid. If it appears CHOSR, it is nothing but aldehyde. CO, it is a ketone. If it is a O, ether. OO, that means ester. NO2 nitrite, CONH2 amide. This is amide. In that particularly we are using of urea. Urea NH2CO NH2. We are using of the formula. First organic compound is synthesized in the laboratory in 1828 by the Hohler. The urea. This is amide only. The functional group is amide only. Okay, that is a you have to remember that. Next is amine. We are using of amine, methylamine, ethylamine, propylamine, or you are using a benzene. Suppose that is called as aniline. If you are using of R group here, methyl instead of C6H5, that is called as aniline. Methyl benzene, that is cyanide, isocyanide, halides. Okay, this is about the classification of organic compound on the basis of the functional group. Okay. Now, one more important topic is hybridization. Why hybridization concept is introduced? What is the necessity to study in these organic compounds actually? Is it study in the organic compounds for that? Is it anything? Means if you see the carbon, organic chemistry means study of the carbon compound. This is the sixth atom in the periodic table. Writing of electronic configuration, generally you are writing as 1s2, 2s2, 2p2 cell, 6 electrons. For this elaboration purpose, I am using of 1s2, 2s2, 2px1, degenerated orbitals. I am writing just clearly. This is degenerate in that. 2s2, 2px, 2py. It is in the ground state of the carbon atom is having off. In this p orbital having of off-filled orbitals means single electrons are present in the px and also py. On z it is 0. According to the valence bond theory, what he says, Cossel and Lewis, is proposed by the Cossel and Lewis. He says if any atom is having of off-filled orbitals, means not fulfilled, off-filled orbitals are present. Those electrons only participating in the bond formation. Due to that, they can form that much of bonds only. So here only 2 electrons are ready to formation of the bond. Why? Because it is off-filled. Only single electron, odd electron is there. It can form only 2 bonds. Carbon can form 2 bonds according to this electronic configuration. But already we told that carbon is having of anomalous properties there. It is a unique property there. It can form tetravalency only. In any organic compound, the carbon is a tetravalency. How it is possible means nothing but in the excited state of carbon, the electron from the 2s orbital is jumped to the p orbital. So it will goes to the pz orbital. Now see how many number of single electrons are present? 4. Due to that reason only, carbon is forming of tetravalency. And not only the tetravalency forming, when you are, this carbon is formation of the tetravalency means 4 carbon single bonds. These are the single bonds that can form. Okay. But here, if you observe that electron, 1 electron belongs to the s orbital, 3r belongs to the p orbital. S orbital is spherical shape one. The shape of the s orbital is spherical. P orbital is
Dumbbell
shape. And one spherical shape, 3 dumbbell shaped orbitals. Okay, 3 dumbbell shape. This is a px, it is a py, it is a pz. When they are combining, you are getting of this is the carbon. All are equal bond length. This the bond length is 1.54 angstroms only. 4 are similar. But why you are combining? A different structures are combining. One spherical shape, 3 dumbbell shape. But we are getting after that one formation will be all are equivalent bonds are formed. Due to that reason, hybridization concept is introduced. Hybridization. Okay. What is hybridization? So nothing but we are already familiar with the hybridization. Are you buying the plants of rose plants? If you see the normal rose plant, how it is, hybrid rose plus hybrid rose plant has not having the not more than the bunch of, that means that is what you call, that is needles. If it is normal, if you see number of them, you can't pluck the flower also. So that much of is there. The hybridization means is mixing something is happens. Here also hybridization, what is there? There is Lewis and Purcell. Mixing of pure orbitals. This is a pure orbital, 2s. This is a 2p, 2px, 2py, 2p. Mixing of pure orbitals of same atom. Same atom. Of same energy. See, these are the words are very important. What you are mixing? Same atom of same energies only. That means which particular electron is belongs to the second orbit or third orbit or fourth. Which electrons you are taking? That electrons only mixing. Here, mixing of pure orbitals of same atom of similar energy to form same number. How many you are mixing? Same number they are forming. 1 plus 3 means 4. They can form the 4 bonds. This is called as hybridization. Again, I am repeating. What is the meaning and definition of the hybridization? Means mixing of pure orbitals of same atom of similar energy to form same number of new equivalent orbitals is called as hybridization. New equivalent hybrid orbitals is called as hybridization. That means here the carbon is having of, this is the orbit. It is the orbit. It is the orbit. It is the orbit. The 4 are equivalent. You see, the dumbbell shapes are similarity will be there. Symmetry will be must be there. The dumbbell shape. While you are drawing in the examination, all are symmetrical. It is not symmetrical here. Okay, this small you are appearing like this. So hybridization concept is introduced like that. Mixing of pure orbitals of same atom of similar energy to form same number of new equivalent orbitals are called as hybridization. Now in the hybridization concept, and our organic compounds, they can exhibit different types of hybridization. The hybridizations are sp3, sp2, and sp. According to your first sem syllabus, only 3 types of hybridizations are there. sp3, sp2, sp hybridization. Okay. So, friends, I already given a concept of the hybridization. If you understand the concept, means it is very easy to understand this one. What is the sp3? Now you take sp3 hybridization. So in the examination, they can ask, write the hybridization. What is hybridization? Explain sp3, sp2, and sp hybridization with examples. They will ask. So first, I given the definition. Next, one by one, I am explaining what is meaning of the sp3 hybridization. Okay, friends. Now, in that only your definition is present. What is sp3, sir? One spherical shaped s orbital, 3 dumbbell shaped p orbital mixing each other. Hybridization means mixing each other to form 4 sp3 hybrid orbital. Why 4? 1 plus 3. We are mixing. You want to get the 4. 4 sp3 hybrid orbitals are formed. These 4 sp3 hybrid orbitals are arranged on the carbon atom as a tetrahedron. The sp3 hybrid orbitals, how they are arranged on the carbon? It is a tetrahedron structure. And the making of the bond angle is 109 degrees 28 minutes. This is called as sp3 hybridization. And following now. So simple. In the examination, you can write as one spherical shaped s orbital, 3 dumbbell shaped p orbital mixing each other to form 4 sp3 hybrid orbitals. This this phenomenon is called as sp3 hybridization. The 4 sp3 hybrid orbital, how they are arranged on the carbon means they arranged in tetrahedron form. And the making of the bond angle, tetrahedron form means the bond angle is 109 degrees 28 minutes. This is enough for the sp3 hybridization. So I'm using the structure. One spherical shaped s orbitals are. This is 2s of the carbon atom. Already just now you saw. Okay. And 3 dumbbell shaped p orbitals are 3 dumbbell shaped p orbital. It belongs to the px. It belongs to the py. It belongs to the pz. They are mixing. You are grinding. Tomorrow or in the morning, you ate the dosa. For the dosa, you take in a chutney. Chutney is made up of the coconut, palli, and remaining other ingredients we are mixing in the grinding. After that, we are having the chutney. Can you separate the coconut and palli after the making of the chutney? You can't. Here also. After the mixing of these pure orbitals, I'm taking up the carbon atom. 1 sp3. 1 dumbbell shaped sp3. This is not dumbbell. It is the shape of orbital. This is sp3. One more sp3. One more sp3. One more sp3. They are arranged. How they are arranged? There must be a tetrahedron bond angle. The bond angle, this is a bond angle. It must be 109 degrees 28 minutes. This is called as tetrahedral bond angle. The 4 covalent bonds which are present on the carbon atom, it is nothing but sp3 hybrid orbital. It is sp3 hybrid orbital. It is sp3 hybrid orbital. It is also sp3. Okay, this is called as sp3 hybridization. In this, we are using of example. They've taken as methane. What is the formula of methane? Methane is
CH4.
That means carbon atom, on the carbon atom, 4 hydrogens are there. This is hybrid orbital. I'm taking the same. Again, I don't want to repeat all these structures. Here, this is a hybrid orbital already formed on this. Okay. Now I'm taking the 4 spherical shaped s orbital. Why 4? This is a H. This is nothing but 1s1. Means it is a spherical shaped H orbital. Oh, 4 are taken. Spherical shape. This is nothing but 1s1. Right? They are mixing of that one. So I'm taking of this particularly, not the bond one. Better what the representation is. It looks nice. Okay. So this spherical shape, how they are arranged, I can write here. Same, you can take. Okay. Now 4, these are belongs to hydrogen, 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 hydrogen. They are overlapping, head-on head overlapping takes place. This is hydrogen. It is hydrogen. It is hydrogen. It is. What about this one? It is sp3 orbital. It is sp3. It is sp3. It is sp3 only. Okay. Now we can represent this one as like this structure. And making out of this bond angle is 109 degrees 28 minutes. Example of ethane. You can take ethane also, similar manner. Okay. We are taken there. Initially, this is the 4 sp3 hybrid orbitals are present. On this 4 sp3, 4 hydrogens are we are combining. These are the pure orbital. It is a hybrid orbital. Pure orbitals are mixing. That means they are head-on head overlapping. Just overlapping will be takes place like this. Overlap takes place. Due to all the overlapping, what happens? A sigma bond is present. This is a sigma. Due to overlapping head on head or tail on tail, Your formation of sigma. Here your formation of sigma bond. Here formation of sigma bond. How many sigma bonds are present in the methane molecule?
4.
Bonds. 4 sigma bonds are present. Okay. That you have to explain for the sp3 hybridization. We have to draw the structures also. Why? Because it's a 10 marks question. I hope you can understand now. This is hybridization. Now we'll go to the next one. Okay. This is about the sp3. Simple. 1 spherical shape, 3 dumbbell shape. We're getting now 4 hybrid orbitals. That 4 hybrid orbitals are, again, you are overlapping with the 4 hydrogens. You're getting the methane molecule. This example. Now we'll go to the sp2 hybridization. My job is very simple now. sp2. If you are observing my board now, see this is sp2. Means 1 spherical shaped s orbital, 2 dumbbell shaped p orbital. 1 dumbbell shaped still we have to present at their position only. We are not using that one in the hybridization. It is a pure only and keep quiet. Only 2 dumbbell shaped p orbital, 1 spherical shaped s orbital. I am mixing. I am taking into the grinder. I am mixing. We are getting off. How many you can get? Hybrid orbitals? Tell me. How many you are mixing? How many you are mixing? 1 plus 2. How much? Is 5 or 6?
3.
1 plus 2. 3. Means 3 hybrid orbitals are formed on the carbon. On the carbon, 3 hybrid orbitals, that is sp2, 3 hybrid orbitals, 3 sp2 hybrid orbitals are formed. These are called as sp2. That means that is called as sp2 hybridization. 1 spherical shaped s orbital, 2 dumbbell shaped p orbital mixing each other form 3 sp2 hybrid orbitals. This phenomenon is called as sp2 hybridization. The 3 sp2 hybrid orbitals are present on the carbon is a tetrahedral bond angle. Sorry, trigonal pyramidal. Trigonal. This is a trigonal. This is a tetrahedral. Okay. This is a trigonal. This is a trigonal. And the making of the bond angle is 120 degrees. This is sp2. Please compare with the sp3, sp2. How these? I am using in this only 2 p orbitals, not 3 p orbitals. Only 2 p orbitals are undergoing the hybridization. 1 s orbital, 2 p orbitals are undergoing the hybridization. You are getting of 3 sp2 hybrid orbitals, which are arranged in the trigonal planar, and the making of the bond angle is 120 degrees. That is called as sp2 hybridization. Now I am taking off the example of this is nothing but I can represent as this one. This is it. Okay. Now I'm taking off ethene or ethylene. The common name is ethylene. So what is that? CH2 double bond CH2. This is the structure of ethene. That means on each carbon, 3 sp2 hybrid orbitals are there. How their structure is formed? Let us see that one. In that hydrogens are 2 hydrogens are there. Okay. Now the carbon, 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals. Now I am taking off 3 sp2. Okay. This is 1 sp2. This is another sp2 on this carbon atom. Right? One more carbon is there. This carbon, one more sp2. One more sp2. Okay, this is sp2. It is also sp2. It is also sp2 on another carbon. But what happened? Between the carbon and carbon, one sp2, another sp2. Head-on head overlapping takes place. Formation of sigma bond. Now, on each carbon atom, 2 sp2 hybrids are present. those are overlapping with the 2 hydrogen atom. Here, each carbon is having the 2 hydrogen atom. Those are spherical, 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 spherical. Now there is a overlapping takes place. There is a head-on-head overlapping. Now again you are having of the sigma bonds here also. Okay, is it finished? Not yet. And each carbon, you are not using the pz orbital, pure orbital is there. Under hybridization, only px, py only hybrid orbitals are used for the hybridization. But PZ's orbital on each carbon is still it is present as a pure. So the pure pz orbital is present. This is a pure pz orbital. Okay, I'm writing this is a pure one. On carbon also, pure is there.
Pi bond is formed.
There is a lateral overlapping takes place. This is head-on-head overlapping. It is a lateral. Due to of the lateral overlapping, only you are getting of the double bond. This lateral overlapping is takes place, you are getting of the pi bond. This is called as ethylene molecule under the sp2 hybridization. Okay, how many ethylene molecule is having of sigma bonds? How many pi bonds? How many sigma? How many pi? 1, 2, 3, 4, 5. 5 sigma bonds. How many pi bonds? 1 pi bond is present in the ethylene molecule. Due to this reason, this particular structure is arranged as. See, this is a sigma, means a single bond. This pi bond, one more bond is present. Now this is the exact structure. And the making of the bond angle, here the bond angle 120. The hybrid orbitals are stays between the 120 degrees is there. That's why you are writing of this one. This is the sp2 hybridization. Are you clear now? Anybody having the doubts? This is about the hybridization concept. Okay, we'll go to the next. Very simple, very simple. Because already I told that if you understand properly the organic chemistry, very easy of that for chemistry among the remaining other branches. Okay, now we'll go to the sp hybridization. Now I am taking off. Okay, now in the sp hybridization, one spherical shaped s orbital, one dumbbell shaped p orbital. Only one dumbbell shaped I am using. One spherical shaped s orbital, one dumbbell shaped p orbital is called as sp2 hybridization. So 1 plus 1, how can you get? How many? 2. 2 sp hybrid orbitals are present. One spherical shaped s orbital, one dumbbell shaped p orbital mixing each other to form 2 sp hybrid orbitals. This phenomenon is called as sp hybridization. These 2 sp hybrid orbitals are arranged on the carbon as linear structure. How it is arranged? Linear structure. To making a bond angle is 180 degrees. Linear means it is a horizontal. We are getting off 180 degrees. So we are getting off on the carbon atom. 1. This is sp. This is sp. Making of the bond angle is 180. See how easy hybridization. You can suppose if you are listen my lesson, immediately you can write in the examination without taking off any notes or anybody. This is that much of essence field of the organic chemistry. One spherical shaped s orbital, one dumbbell shaped p orbital mixing each other to form 2 sp hybrid orbitals. The 2 sp hybrid orbitals are arranged on the carbon end in linear structure, making of the bond angle is 180 degrees. Example, we can take as acetylene. Acetylene is a common name. Actually, the IUPAC name is ethyne. The structure of this one is ethane structure. This is ethane. See here also 2 carbon atoms are there. 2 carbon atoms are undergoing this one. Again you can write that 2 carbon atoms, one sp, another sp. Okay, one more carbon is there. On that also one sp is there. One sp is there. This sp head on head overlapping takes place. Sigma bond is formed, and each carbon atom one hydrogen is there. That is a spherical. That is a spherical. There is again head on head overlapping. There is a formation of sigma bond. Over. How many sigma bonds are formed now? 3 sigma. Okay. Now on each carbon, pure orbitals are there still. Those are not hybridized during the hybridization concept. So pure orbital, what are? One is py, another is pz. This is py. Another is pz. On each carbon, here also one py, one pz. Okay. These 2 pure orbitals are lateral overlapping takes place. Lateral means side by overlap takes place. So py, 1 pi bond, pz, 1 pi bond. This is called as ethylene molecule. You can say represented as like this. Sorry. Okay. This is the representation of that one. 1 sigma means 1 single bond. Pi bonds 2 are there. 2 pi bonds are present. This is the sigma bond is there. This is the ethylene molecule. Which is the making of the bond angle is how much? The bond angle, here the bond angle carbon between the carbon, 180 degrees. This is a triple bond unsaturated alkene. This is alkyne is there. Okay. So I hope you can clearly understand the concept of this one. This is called as hybridization. In syllabus point of view, organic part, we are having only 3 hybridization: sp3, sp2, sp hybridizations only. Okay. In your examination, it is also very, very, very important. That much I can say. I don't want to repeat, sir, which is an important question. Don't ask. Everything is the important. So why I don't know the students are asking the importance are. So if you understand the concept, you can write that one. What is there? On the basis of the concept only, the questions are created. You can write the answer. That's it. So I don't want to say like that because nowadays they are simplifying. Sir, which is suppose I am giving of 20 questions, means among the 20 questions, sir, which is important again. If suppose I am at 10, sir, among the 10 also you can give the few questions, sir, again important. If I give the only one, sir, that's enough. Is it pass mark? You will get the one question. You can't get now. So that's why whatever the topics I am explaining in the classroom, that is nothing but important only. Sri Lakshmi, what happened if I can't read the message? Okay, fine, ma. Anyhow, I hope you can understand this concept, na? Hybridization. Okay, thank you for your complimentation. But the thing is, ma, here why I'm explaining this, because it's a very easy chemistry. In that chemistry, I'm saying the organic chemistry is a very, very easy when you are understanding. Okay, when you are understanding, if it is a very easy, the systematic procedure is there. It is a listic mathematics, stereochemistry, whatever. If you are following the stereochemistry, you will get the equations. Okay, we will go to the next topic. We are having the only little bit of time is there. I know, and moreover, this is the last class. Sure, definitely I will give them away because today is the last class. We are having plenty of the topics are there left over. So if you are anybody interested to understand the concept, or if you are having of during your studies, anybody having of the doubts, you can clarify by directly contact with me. My mobile number is 988 577 214. Okay, I'm writing my mobile number 988 577 214. You can contact directly. You can ask, sir, I am the first sem student. I'm having those doubts. Can you clarify? I'll definitely clarify that one. First of all, you put as a WhatsApp message. So because on that time I'm available or not. If you are not lifting, you can feel. Okay. So that just put on the message in the WhatsApp. I can explain in the WhatsApp or else directly I can speak to you. Okay. No problem for that. I will go to the nomenclature. Okay. Very important. So why? Because what is the necessity of the nomenclature? Suppose you are there in your family. After the born, what happens? Your mother, father, or your elder says that you can put as a name. Otherwise, Pinky, Laddu, something puppy, you are calling like that. You have the specific name you require. Here also, millions of the organic compounds are preparing in the laboratory every year. Every year, millions. Almost all my knowledge, 50 to 1 lakh compounds are synthesizing in the laboratories. Organic compounds only, every time. So you have to keep the name, then only you can represent it or you can identify the compound. For that purpose, the IUPAC nomenclature is put forth. Before that, we are having of the names on the basis of history only. Already I told that urea first discovered in the laboratory, that is by the Euler. Why? Because all the mammals urine consisting of urea. So that you are called as a urea. Similar way, acetic acids are acetum is the Latin word. Acetum means it is a vinegar. Vinegar means acetic acid. We are using for your household purpose. That's why it is called as acetic acid. Again, the question, important questions are okay. I will give the important questions also, no doubt at all. Okay. So, first of all, completion of my syllabus. That is important. But keep in mind is those who are attending my class, I'm assured to you, whatever the prescribed syllabus is given for your first sem, I can clarify the doubts, important question, everything. But not now, because you are having only few minutes are left. I will complete the topic, that is the nomenclature. Then you can come with the whatever the WhatsApp group. I will clarify in that one. Okay. First nomenclature for that purpose. Startingly, few compounds only prepared in the laboratory. That's why on the basis of history, they are called as a names. But after that, if you are listening my class, is it necessary to buy the test papers? Who are writing the test paper? Illiterate writing the test papers. My chemistry, suppose, if you see the chemistry test, what you call, that is a test paper. Blunders of mistakes are there. I don't want to suggest the test paper, someone. Science always, don't go the test paper. No need of very good syllabus. Right? Okay? You have the prescribed book is there. It's a beautiful book is given. You go through that book. Prepare the notes. Yes. Prepare yourself notes. You will get the idea. If you are having any doubt, I am here to clarify. Okay, na? Right. Now coming to my topic, nomenclature. So the nomenclature, why it is put for me is because of that one. So in the 1952, actually it is actual 1924, a Geneva summit is present. In that, there is the International Union of Chemistry is there. Then after it is discovered in 1934, one month society is developed. That is also discovered. And lastly, 1945, IUPAC nomenclature society is formed. IUPAC. What do you mean by IUPAC? International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Suppose today I prepared any one of the organic compound. First, I have to apply this society. It is in the Geneva. Okay. The norms are given. The rules and regulations are given. If you are having of these rules only, you can apply that one. So, according to the norms only, I prepared that organic compound. So So first of all, I have to submit my literature. This is the compound I prepared according to your norms also. I can put as this name when you agree or not. I can submit one. The society members can think about that one. They can study that one. Then only, if they are satisfied, then only they can announce the name of that organic compound. That is a society. And the society IUPAC nomenclature. What they given the some norms. What are the rules are there? Let us discuss about this one, IUPAC nomenclature. Okay, friends. Now the IUPAC nomenclature. What is the IUPAC nomenclature? So what is this? If any organic compound, please listen. Very simple. This is also. If any organic compound, X is the organic compound is there. First of all, this X organic compound is divided into 3 parts. Don't cut it. Just I'm using. You are using of 3 parts. What are the 3 parts? First is the root word. First is the root word. Second is the primary suffix. Third is the secondary suffix. But in your book, it is given as a 4. Let us understand first. First, you have to understand these 3. Then I will go to the 4th one. I don't want to go first, 4th one. Okay? They will give another first one, one other is there. I don't want to go there. First is the root one. So, whatever the unknown organic compound is X is given, in that you have to find out the root word. What do you use the root word? Root word means how many number of carbon atoms are present in unknown organic compound. That tells the root word. Understand? How many number of carbon elements are present in unknown organic compound is gives as a root word. Suppose in an unknown organic compound, you are having of the carbon atoms are only 2. Already given in that one. If the 2 is called as it, if the 5 is called as pent, if is a 8 is called as oct, like that you are given as the Roman letters are given. One is myth, it, prof, but, pent, ex, ept, oct, nun, dec. 10 means 10. That is called as a root word. I hope understand. Root word indicates number of carbon atoms. Now coming to the primary suffix. Very easy. Primary suffix means the carbon atoms are arranged in a single bond or double bond or triple bond. If it is a single bond, you can call as ene. If it is a double bond, sorry, ane. If it is double bond, is called as ene. If it is a triple bond, is called as ine. Already I have explained this one. Single bond is called as ane. Double bond is called as ene. Triple bond ine. That is indicate the primary suffix. That means the given, that is the unknown organic compound is saturated or unsaturated. We are giving that idea. So root word means number of carbon atom. It is called as alk. Alk is the root word. When you combine with alk plus ane, alkane. Alk plus ene, alkene. Alk plus ine, alkyne. That's it. Your first sem. Rinky saw, yes sir. Okay, right. Now, this is the root word is over. I have number of carbon atom. Primary suffix means whether it is a saturated or unsaturated. Single bond or double bond or triple bond. Second suffix. What are the functional group is present? Just now we are classified the functional groups. What are the functional group present in the main chain? Whether it is acid is there, that is a carboxylic acid. This is an acid. You can write as oic acid. So alk, ane, oic acid. Just remove the E. Alkanoic acid. See the organic compound you are named as. Root word is alk. You don't know how many number of carbon atoms. It is a saturated. Ane. Remove the E. It is functional group is acid is there. You can put as oic acid. Alkanoic acid. So just I have taken. This is a compound. How many number of carbon atoms are there? 2. 2 means what? Root word it. It is a saturated, single bond is there. means an, an. It plus an. What is the functional group? Oic acid. So total name is ethanoic acid. What is the name of the IUPAC name? Ethanoic acid. But the common name is acetic acid. Common name is acetic acid. Why it is called as acetic acid? Common name? The history. Acetum. Acetum means Latin word is the red ants. Okay. Acetic acid. Sorry. Vinegar. We are having of vinegar. Acetum. So it is called as a ethanoic. Is a IUPAC name is ethanoic. Like that we are rooting the root word, primary suffix and secondary suffix. On the basis of this one, you can name it as an organic compound. Next is you are having of one more is there in this particularly. In your book, it is given as not only the 3, one more extra is then that is given as a first one. Prefix. I lost is saying every time. First, we have to understand the 3. Root word means how many number of carbon atoms are present. That indicates. Second is primary suffix, whether it is saturated or unsaturated. Third is secondary suffix. That is what are the functional group present in a given organic compound. Now coming to the prefix. Prefix is nothing but your name is there. Before that, your surname is there. Surname. K, A, R, whatever you are writing now, that is surname. This is called as a prefix. Prefix means what? Sir, it is nothing but any substitution. This is a root word. This is a root is there. That means we are having a trunk. A plant is having a trunk. On the trunk, number of branches will coming. That indicates the prefix. If it is the prefix is 1-methyl. This is a CS3. It is called as a methyl. Suppose C2H5, it is called as ethyl. Means N you are coming as, if it is a 4 hydrogens are there, methane. 1 hydrogen is left, it is called as methyl, ethyl. Suppose X is halide. Like that, it is indicated as a prefix. It is called as a suffix. See the word difference. Suffix means after the root word you are writing. Prefix means before the root word you are writing. Here, prefix is there. Prefix is here. In this compound, it is not there prefix. But if you are having of any substitution, any branch, you have to write the first prefix, then only go to the carbon compound. That is the organic compound. These are called the branches. Okay. Now this is the main important of the nomenclature. And the nomenclature, there is a 5 points are there. Already time up. Within few minutes, I can conclude this particular 5 points. What are the main important points given by the IUPAC nomenclature is? First point is given as select the longest chain of carbon atom, whether it is a straight chain or branching one. Select the longest chain means, sir. So I don't know that actually it will take you 2 hours time, Amma. So select the long chain means see. This is a carbon compounds. This is a skeleton I am written. Just skeleton I am written. It is a straight chain. It is a branched one. Select the large number of carbon atoms. Suppose I am selecting the straight chain. 1, 2, 3, 4, 5 carbon atoms are there. Root word is 5. But if I am selecting the branched one, 1, 2, 3, 4, 5, 6, 7. Which is the more? 7 is the more. So select the branch, not straight chain. That is the first rule indicates. The first rule indicates select the long chain, whether it is a straight chain or a branched chain. Now coming to the second one. The substitution present, it should be present in minimum number of carbon atom. That means least numbered carbon atom. Substitution means branch. Just now they have the prefix. That branch is there, suppose. Just now I selected 1, 2, 3, 4, 5, 6, 7. On this branch is there. This is the branch. So second rule is what is saying? Select the branch which comes under the least numbered carbon atom. So here you are getting the 4th number carbon atom. The substitution is there. Coming to here 1, 2, 3, 4. Here also same. Like this is also correct. Like this it is also correct. Suppose the carbon atoms are less, only 6 carbon atoms are there. Straight chain is 5, branched is a 6. Now the carbon atoms are, if you are selecting, this is a wrong. Why? Because on the 4th carbon substitution is coming. But I am selecting like this. Now the carbon atom is coming on 3rd. Least numbered carbon atom. Important. Least numbered carbon atom is important. So this is the wrong. Only this is the correct. What is the name of this one? This is cutting one methyl. So 3-methyl. Prefix is over. How many number of carbon atoms are there? 1, 2, 3, 4, 5, 6. X. Root word. It is a primary suffix. A 3-methyl hexane. This is the second rule is given. Third rule. If more than one substitution, here only one is there. If it is more than one is present, more than one is present. Now, what is say? We have to write the substitution according to the alphabetical orders. We have to write the alphabetical order. Now you select the first longest chain. Which one is the longest one? Branched only longest one. But here substitution is present on the second carbon. Here substitution is present on the third carbon. So select like this only. Now this is the correct way. Previous it is okay, but now it is not correct. On this second is the chloro, and the 4th is the methyl group according to alphabetical order, which is comes under C or M. C only first. So 2 chloro, 3 methyl hexane. This is the third rule. If more than one substitution is present, write it that substitution on according to the alphabetical order, dictionary model. Okay, this is the third rule. Coming to the 4th rule, I am going to the 4th rule. That is the one. If suppose, here only I am taking a functional group, secondary suffix is present. The functional group must, whatever the functional group carbon is, blindly put as is the first carbon. It is a line. So the selection of the longest chain must be like this. Not previously you are using of this one. Now select the first carbon is here only. Why? This is a functional group. That is a king of this compound. So functional group 1, 2, 3, 4 only. Branch. If you go to the state, 1, 2, 3, 4, 5 is the longest chain. On the second carbon, there is a branch is there. And the second carbon, there is a branch. What is the branch? It is a methyl, CH2 here. This is CH3. Total how many? C2H5. That means ethyl. 2 ethyl. What is this? Number of carbon atoms, root word 5. Pent. It is a saturated N, but here on the one carbon, secondary suffix is oic acid. Pentanoic acid. 2-ethyl pentanoic acid. These are the rules applied by the IUPAC nomenclature. Sometimes we are getting off the 5 marks also from this. They will give the structure, write the IUPAC nomenclature. I can hope understand that one also. Why? Because already 10 minutes over for this topic. Okay. So if you have any doubt, means please post the whatever the doubts in my WhatsApp. Okay. I will clarify to you. This is about the organic chemistry. Next is not only the isomerism is also left. Isomerism is also very important. In this first chapter, organic chemistry, we are having a classification of organic compound, classification on the basis of functional group. Second question, hybridization. Third question, nomenclature. Fourth question, fifth question is isomerism. 5 essay type 5-10 marks questions are there in the first chapter itself. Prepare. Okay. Any more doubts? I'm leaving. Why? Because already 10 minutes. They're cautioning to me. Okay. How many are there? 19 members only. Okay, Lakshmi. Right. You can directly contact. Which one, Emma? What is first means? Question. Okay, classification of organic compounds. Last Sunday I will explain. Second question is classification of organic compound on the basis of functional group. Third question is hybridization. Fourth question is nomenclature. Fifth question is isomerism. 5 essay types, compulsory 1, compulsory 200%. Without these question, won't having of question paper, your question paper. That's it. I can open your question paper also. Right? Right. So, any more? Right. We are having the next class now. Again, but in that one, so you're getting of any doubts, means you can contact. Right, Amma. All the best for your exams.